Okay, so 8.4, very similar to congruent triangles. So once you've proven triangles congruent, do you remember how after these triangles were congruent to each other, we were able to pull out CPC-TC? And what that meant is all the parts were congruent to each other. Very similar to similarity. So once we can get these triangles to be similar to each other, what we know, okay, so once, that's a C, not an E. Once the triangles are similar, then we know two things for sure. Again, you first have to get the triangles similar. So watch the video for 8.3 if you're unsure how to do that. Once the triangles are similar to each other, corresponding sides are proportionate. Okay? Once the triangles are similar, then we know that the corresponding sides are proportionate, and two, that all of the corresponding angles have to be congruent to each other. Once the triangles are similar, so you first need to prove that the triangles are similar. So I'm going to show you an example of what one of these proofs is going to look like. So I'm going to give you, given that we have parallelogram ABCD, and also angle AJ, no, I'm not going to do AJ. I'm going to do angle BJD is congruent to angle DKB. Okay, and I'm going to draw the picture. So I have this parallelogram here, and we're going to draw some things here. And we have A, B, C, D is a parallelogram. Okay, and we have some stuff there. We are going to prove that AJ over CK is equal to JD over KB. Okay, so we are going to prove this. Once again, in order for us to prove that the sides are proportionate, we need to first get the triangles to be similar. So again, if it helps you to use colors, sometimes I like to highlight with colors. So they're trying for us to prove that this blue side over this blue side, the proportion of that should be equal to the proportion of this orange side over this orange side. So first, let's go ahead and get these triangles to be similar to each other. Okay, so ways to get triangles similar to each other. We need either two angles, right? We need angle, angle, side, side, side similarity, or side, angle, side similarity. 99% of the time, you're just looking for two angles. So let's go ahead and look at the given information. So I have parallelogram, ABCD. And if I have a parallelogram, I believe it is true that we have opposite angles that are congruent to each other. So therefore, I know that angle A has to be congruent to angle C. And again, if you have a parallelogram, then opposite angles have to be congruent to each other. So I know those angles are congruent to each other. Let's write down our next given information. Angle BJD is congruent to angle DKB. Okay, so they're telling me that this outside angle right here is congruent to this outside angle right here. Well, I would then know that because those angles are congruent, their supplements have to be congruent. So I'm going to say angle AJD has to be congruent to angle BKC. And the reason would be if angles are congruent, their supplements are congruent. Okay, I forgot to put my reason 3 was given. Now that we have a red angle that is congruent and a green angle that is congruent, we have two angles that are congruent to each other, it is justifiable for me to assume that triangle AJD is similar, AJD is similar to CKB, and that is by angle similarity. You can see that in step 2 and step 4. Once these triangles are similar, I can now say that their sides, and you guys can see AJ is the first two, CK is the next two. Okay, when you put those sides over each other or create a ratio, and then you see JD and KB, when you create that ratio, it has to be equal to each other. So if triangles are similar, then corresponding sides are proportionate. Again, because those triangles are similar to each other, I know that the sides have to be proportionate, okay? The last thing I want to talk to you guys about is shadow problems that you guys are going to encounter. For example, let me go ahead, I will just type this out. So let's say we have a tree and it casts a 20-meter shadow. Nearby, a 6-meter pole casts an 8-meter shadow. How tall was the tree? Okay, so I know you guys are thinking similarity, set it up, but I want to show you guys that this is actually, like if you have this tree and we don't know how tall it is, but it is casting a 20-meter shadow. The reason that we can do this, guys, again, is actually because of similar triangles. If the sun is up here, if this is my sun, okay, and you have a pole over here, and that pole is 6 meters, and it is casting an 8-meter shadow. Again, a shadow is coming off of this straight up and down pole and assuming the straight up and down tree at a 90-degree angle. Therefore, we have this angle that is congruent to this angle. Okay, we have those angles congruent. And we also have the angles of the sun that should be congruent to each other because they're nearby each other. Okay, so these triangles are similar by angle. Therefore, we can set up a proportion. So the height of my tree over the height of my pole should be equal to the shadow of my tree over the shadow of my pole. Okay, and this is how similarity works. And then if you want, you can go ahead and cross multiply. I personally would reduce first. Like, why would I leave this as 20 over 8? And I always just keep dividing, like I would divide this by 4. So this would be 5 over 2. And then I can easily see that to get from 2 to 6, you multiply by 3. So I would multiply by 3, x is 15. If that is something that is like, what is she doing? Just straight up cross multiply. Okay, so I know that x is 15, but if you don't like that, go ahead and cross multiply. We have 8x is equal to 120 divided by 8, x is equal to 120 divided by 8. Again, I would do that in my head. I would do 80 plus 40 is 120, and then it's easily to divide both of those by 8. You get 10 and 5, and that is why x is 15 meters. Okay, so we know that the tree was 15 meters tall. Okay, so you can also use proportions and similarity with angle to identify missing information.